Hello. This is the demo regarding the desktop application which can configure Solidworks assembly. So our basic goal here is like we are trying to make this application totally free of cost, so that a normal design engineer can get the idea of design automation and how this thing works. So let's begin. So with our download, like once you download this particular application, you will get this zip folder. So I will take you through all the steps that need to be done to configure a simple fish tank, but the principles and the process can be applied to any assembly. So let's begin. So let's first go and extract this. So we will extract everything here. Okay, so once extracted, once you go inside this folder, let me change the view, medium icons. So once you go inside the folder, so this is the folder where we have the application, and this is the folder where we have a sample file which is a fish tank. So let me open it quickly and show you the assembly. Allow it some time. Solidworks is getting started. Okay, so let me bring it to the screen properly. So this is the fish tank. So let me change the transparency. Yes. Okay, awesome. So you can see this is just a box. So what we will be doing is in this video we will configure this particular box where the user will input the length, the width and the height, and according to that this whole box will get created. So let's begin. So first you need to analyze the assembly, and then there are few initial steps, and these steps need to be done only once. So the step is basic, all the things that we use here is something that a normal engineer always does, the utilities and other things. So we are using Microsoft Excel to create our rule engine, and as you know, Microsoft Excel is very good with linear mathematical calculations, and that gives us an advantage, like how and up to what level we can configure, as well as we can create custom formulas inside Excel, and also if you want to have much more customization, we can go with Excel macros using Excel APIs, which will allow us to create more complex calculations. So yeah, let's begin. So first what we need to do, you need to go into this config file. You need to edit it. You can open it in Notepad, as well as Notepad++ is a good option. So the things that you need to change here is this keys. So the first key is the CAD Excel sheet. Like this is the sheet from where all the dimensions and other things will get controlled. So let's put the sheet location here first. So our sheet is like located in this particular location. You can locate this Excel sheet anywhere in your system, just from the system where you are starting the console application. That system need to have access to that particular path. So let's copy the location of the Excel sheet. So this is a best practice to copy the whole path, and once you are done with it, just go here and paste the Excel path. I will take you through what are the things available in this Excel, and this is where you do all of your work, and the utility will read this Excel and make the changes accordingly. So the next key that you need to change is the Solidworks version. So whatever version that you are using, you need to mention the key, the value over here. So these are the sample values that is available. Let's say if you are using 2018, then you need to mention 26, 27, 28. So this so currently in this system I'm using Solidworks 2019, so you need to put 27 here. Once you're done with it, just go ahead and save it, and then close your Notepad++. So now the application is configured to use this particular Excel. So now let's open this Excel and let's go through different things that is available over here. So let me open this. Okay, now the first thing is you need to go to the workflow. So you can bring this sheet at front, but as this is something where we this is the sheet where we configure every operation that the configurator is going to do. So you need to go to workflow, and you can see there are different options available here. So currently with the free version we are giving the CAD modify, like you can modify any 3D CAD model for the configurations. So in free currently we are trying to add more functionalities like drawing conversion and other things, but that is not currently available here. So for now we have the CAD modify, and there are other options like drawing modify if you want to change scales and other things, but those drawing related modifications are currently not available on the free version. So this is to evaluate whether your assembly can be configured or not. This is totally free and can be used. You can use this for your own creating your own configurations, or you can ask us to do the same. So let's go through each arguments here. So you need to mention that this need to be same as the text mentioned over here, initiate CAD modify, because if you change this string, the utility will not going to do any changes to the CAD model. So this need to be fixed. So once this is done, the next thing is from where you want to open your master assembly or part that you want to modify. So let's say currently my file that I want to modify is located at, if I go to sample files, master model. So this is the assembly that I want to modify. If you want to modify a single part, you can just directly mention the part name part. So this is the assembly that I want to modify. Now let's go here, Control C, and what I need to do, I need to as a best practice, we always need to capture the full path of the assembly. Let's go here, let's click on this one, C, and let's paste it here. So this is done. Now our utility will work in this particular assembly. Now once this is done, your utility is totally set up. Now you can run the utility to make the changes, but what changes it will do. So currently we have different sheet here which related to different functionalities which are trying to bring up on the initiate CAD modify. But you can use these three sheets like dimension. If you have any dimensional changes like size changes, those things need to be present. I will take you through all the things and what does all this column means. But if you have any size change, so that need to be mentioned here. If you have any shape data change, like if you want to suppress unsuppress some features, some parts, some assemblies, that need to like if you want to suppress unsuppress some components, that need to come here in this particular sheet. And if you want to suppress and unsuppress some of the features of the components, that need to come in this sheet. See, so we will go through all these things. So once you are done with the workflow sheet, the second thing you will do is you need to come to this input sheet where you need to define all the inputs, like the variables that are going to control everything of your assembly. So let's try to do it in this way. This is really helpful if you keep both Solidworks and the Excel sheet on the same screen, so that you can so that you can always visualize, and like it will be easier. Okay, now see, this will be our length, this will be our width, and this will be height, and you see there is a thickness also. So let's do it this way. You can control the thickness, or if you want to keep it a constant, then that's also completely okay. So here you can see in the sheet we have variable name, variable value, and variable type. So let's talk about variable type first. So there are two kind of variables that you can create. One is input and one is output. So output are some variables which you calculate, and inputs are some variable which the user will going to input. So this is a basic bare bone of the application. Like here the mechanical engineer will control everything from the Excel sheet, but once you move to the cloud platform, you will be able to create a UI for non-engineering users or your sales or other departments. But for now, this is for like how the engineers will be able to create the utility. So here you can mention inputs and output. Most of the time we have inputs, and outputs we are going to calculate in the size sheets. So for this particular example, we have this length, width, height, and let me add another one, thickness, and let me put a dummy value of 0.8, and let me put this as 200. Okay, and you need to always mention what type of variable it is. Now the next important thing is when you will be using this cells in your formulas and other thing, it's a good practice to name this particular cells. You named it here, but it will be very much helpful when you will be creating formulas, like you will see it down the course. When you will create the formulas, it will be easier if you name them. So to name them, you can click on the cell and you can click on define name, and you can go here and select a name for this. So now this is our length. Let's click OK. Okay, so it's saying the name is already available. Maybe I had it on some column. So let's define it as demo length. Okay, click OK. Now this will be our demo width. So let's see if it change. No, you need to go here, define. So this is a one-time activity. When you define your variables, you need to do this, but remember to put a name that you can understand, a real real world name, so that you can understand it later on. Now let's call this as define name, and this will be demo height. Click OK, and the next one is thickness. So let's go here. Sorry, this will be a little it may looks like a little trouble to do, but once you are expert on this, this will be a piece of cake. So demo thickness. Okay, now click OK. So now we have defined all our variables. Now let's connect this variable to our actual CAD dimensions. So this is the sheet. Yeah, one more thing. So let's say if you want to create any remarks, you can put your remarks here for a better understanding. Now let's go to the dimension sheet. So this also have the same kind of thing, like dimension names, name, model type, values, and comments. So in model type you have both assembly and part. Let's say if you want to change some dimensions at assembly level, you need to select assembly, and if you have something at part level, then you need to select part. Okay, and these are the value that will going to come from the input sheet. So whenever some user will change this inputs will get used by different formulas on the dimension sheet, and accordingly it will calculate all the dimensions. So now let's go through a few of them. So let's first start with, whenever you change a model, you have some design intent. So for this particular model, what we have is like we will the user will change the length, height, and width, and all other plates and other things will get changed accordingly. So we will first start with the base. Now let's go to base, and now let's see, check the sketch. So now if you check, I assume that you have the basic understanding of Solidworks modeling and how the design intent works, and all other things. So that understanding is required to do this. So I am assuming that you already have that understanding, but if you don't have that particular understanding, like how SolidWorks works and how you can utilize it to create your own configurators, then please contact us. We would be happy to provide you a course. So at the end of this, you'll be able to see our contacts, and you can directly log into www.cloudcadai.com, and you'll get all the informations and contact us from there. So let's call this dimensions. Now this, it's a best practice if you let me do it this way. Save, because it's an older version file. Let me first convert it, and then we will not get that particular error. Okay, save. why, what is happening? So let's go to file and let's go to save and let's save all. So yeah, it changed. Let's begin now. Let's go to sketch back again and let's do a double click here. So there are two ways to do this. The first one, you can change the name of the dimensions so that you can understand it more well later on, or otherwise you can keep the dimension name as it is and you can mention it over there. Okay, so let's take this example d1 at that sketch 1. It doesn't allow you to copy, so that's something that you need to do. So you can put it like this, d1 sketch 1, and the model name is base. You can copy it from here by doing a rename, or you can type it. Then the next part is you need to mention whether it's a part or assembly. And now the important is this particular column. So all the calculations that you are going to do for any dimension or shape or anything, that need to come in the value. So how you, please put a little focus here, because this is the most important part. So how we will create the values for this particular dimensions. So let's say equal to, now let's assume this d1 is a length. So what we will do, so once you click, okay, now you can see we have all the cell names here. So as I said, told you earlier, if you keep the names, it will be easier for you to find that particular cell. Otherwise you need to mention the cell value accordingly. Okay, so for now let's select demo length and press enter. See, the value from your input sheet came here. So this is how it's going to work. Now let's call this dimension d2. Let's cross this. Now let's take this dimension and let's call this d2 as width. Okay, as I told you, like you can follow both the options. Now let's say if this is a width, then what I need to do is I need to replace this d2 with the width value. Now and how this width is going to calculate it, this should come from the demo width cell that we created earlier. So let's click on that and the value came. Now d1 boss, okay, now we configured the sketch. Now the height that this bottom plate is getting, see, this is the bottom plate. Let me show it to you. Let me isolate it. Yes, so this is the bottom plate. So now we calculated like we provided our equation for this length and width calculation. Now let's do about this thickness, and how this thickness is coming. This is coming from the boss extrude. Now okay, it's little bit tricky. Let's see. Yes, we got it. So this is d1 boss dash extrude 1. It's a let me put it in that way. So d1 boss 1 base, and how the value will going to come, it's come from the thickness. Okay, so you can notice here that this particular part file doesn't have to do anything with the height. So accordingly we haven't created any relation of this plate with the height. Now so let's see how our utility behaves. Now as you did that, once you are done with it, you need to go file and save. Now if we run our utility will only change these 3 dimensions. Okay, now let's see how this works. So I will go ahead and close Solidworks, or you can keep it open when you do all this test things, but for now let's do cancel that because we don't want to save it, and close Solidworks window. Don't save. Now let's go to our folder where we have our utility. Now I'll go here and do a right click on the exe, and I'll say run as administrator. So what the utility will do now, it will launch Solidworks, and as we mentioned from which location it needs the Excel sheet, it will read the Excel sheet and from the Excel sheet it will find out which assembly need to open, because we mentioned it on the Excel sheet, and after that it will open the assembly that we mentioned on the Excel sheet, and then it will go to your input sheet and other sheets accordingly to make the changes to that particular assembly. So currently when it will run, it will render Solidworks in your system, so that will going to take some time. Let's wait. It launched, so it's reading from the Excel sheet. Make sure that you close the Excel once you are done with the save. So now it will make the change. Now as we only change the base part, so what will happen, the assembly is going to break, see. But if you check the sketch has been changed to the values that we mentioned. Okay, you see 900, 610. Now if you go to the assembly, oh, that's 350. Let's okay, it's still 610 because the name we provided to it doesn't worked out. So now after changing the name, click on the tick button, and from the next time onwards this assembly will open. So this is the basic thing that you need to do to configure. Now let's go ahead and correct this assembly. So the practice that we follow in here, we first break the assembly and then go one by one to correct it, and then we put all the things that needed to be corrected on this particular sheet. So I will take you through this. Now as this part changed, what are the things that need to be changed? This particular part also need to be changed. Now let's see, D1 sketch 1 front or back. So let's mention this, D1 at the rate sketch 1, and the part name is front dot back. Okay, now this need to be changed, and this is a part, and with which it's need to be connected, it need to be connected with the length. Let's call it demo L. Sorry for that. Done. Okay, now what other things need to be changed? This 600. Now see, this 600 need to be a this 600 need to be connected to the height. Okay, cross D2 at the rate. You can create your own snippets to add here, and the part name is front dot back, and again part, and this need to be connected with demo height. Okay, so this way you will do all these changes. And similarly, if you want to connect the thickness, let's get the thickness value, boss extrude, let's copy this and paste it here, and just drag it here and drag it here, and let's copy this and paste it here, because anyway thickness is going to be same, right? Now okay, so what we have created here is this part will go from here to here. Now let's say if I want to modify this particular part. Okay, so what I need to do is I don't want to have the overlaps, like this particular part should not collide with this one. So how I'm going to do this? Now let's see which part this is. Let's first get out of the assembly mode, and let's open this and see D1 sketch 1 side. So its name is D1 at the rate sketch 1 side. Okay, no, side should not be here, so let's put it here, and this is also a part. Now what will be the value of this one? So the value of this one will be equals to because we don't want to overlap, right? So how we are going to do that? So value will be demo width minus 2, because we don't want to have the overlap on both sides, that's why a 2, minus what we need to do, we need to minus the thickness, demo thickness. Okay, so it says it's having a typo. Let's see. Okay, so the value is coming properly. So this is how you are going to calculate and create equation of all these things. Always remember, okay, so this formulas, you can create custom formulas inside Excel which you can use to calculate all this value. Just go through how you can create a custom formula in Excel, and if you don't able to get anything, or if you need more help, then please contact us. Similarly, we will change the height. This height is D2 sketch 1. Okay, so once you start doing this, you will figure out that most of the text, sorry for this one, most of the texts are quite similar. So you can create your own snippets, or you can manually put it here. We are trying to work on things like you can directly grab it from Solidworks, but with this open and free version, this is how we are doing it. And currently we have configured assemblies with 10,000 parts following this process. So this is a one-time activity, and this will help you understand more about your design. So let's do this. This will going to be equals to height. Okay, and height is demo height. Okay, so this is done. Now let's go and make changes to all other parts. So this is okay, we will going to have a Moss extrude as well. Most of the time it's always same, but please cross check always the feature names, because if you made mistake in the feature name, that particular thing is not going to change. Okay, so we have side 1 and 2, so I think both are connected, and if you change anything on the side, because they are instances, so you should like, I assume that you know how instances work, and with that logic, if you change one side, the other side will change automatically, and the thickness will again going to be the thickness value that we mentioned. Okay, now the sides are done. Now let's try to modify front, back. Front backs are also done. Oh great. So see, this is what I was talking about. If you have a proper design intent, let's say if you created these two parts differently, then you would have to mention all the equations over here. But as like we already knew that these two parts are going to be same always, what we ended up doing is create an instance, and that will how that will benefited us, like we don't have to create much more equations for them. Okay, now so this is configured. Let's save this for now, and let's run it. Okay, I will okay, let's run it on this open file only, because when you are doing the testings, it will be easier if you if the files are kept open and you can constantly working on it. So let's go ahead, do a right click and run as administrator. So this is a dumb application which just takes the values from your Excel sheet and modify accordingly in the CAD model. So let's see how it behaves this time. No, it did something, but I think we need to make some more changes. What happened? Let's see, do we have anything? No. Okay, let's try to unsuppress them and see what's the problem. So it's a best practice, like the best practice is you should always break the assembly and then try to create it. So you can see the problem here is like this particular dimension hasn't been changed, and this is connected with side. Okay, so let's go ahead and try to create that value. D2 sketch 1 200. Okay, yeah, the problem, we found the problem, but D2 sketch 1, D2 sketch, oh, this is not sketch 2, this should be sketch 1. See, normal mistake can make, and once you modify this, you'll be able to understand how and how the things are connected and what change you need to make. So now this is done. Now let's again resave it and again rerun our application. So once you run it back, it will go and modify according to the changes you made. Okay, so this totally depends on the hardware that you have. So it's done with the reading. Oh, it's again launching Solidworks. Okay, so that's a little strange, it will not allow to modify. Okay, it modified, but the problem is the value D1 sketch 1, D1 sketch 1 site 334, that's wrong. D2 sketch 1, okay, I don't understand because we have, okay, I got the problem. We have changed the dimension name, but we never saved the particular assembly, and that's why this happened. So let's save it. Now let's re-verify, and this is width now. Awesome. Now let's run this again. Okay, let's call this and run this admin. Okay, I'm not sure if it will launch. Okay, it's working on this one. See, this time everything worked properly. So this is what I was talking about, and the same principle you can follow for any assembly, however big the size is. If you configured it well and connect with your mathematical equations, that will going to work well. So as a side note, we have used this particular utility to create bigger assemblies, and we have used custom math equations. We created our own equations utilities inside Excel, which can calculate different dimensions, and also we have implemented techniques like calculus to find out the optimized solutions for your geometries. So yes, you can evaluate this utility on your own, and if you want to move ahead or go with our product and our services, then please do let us know. So saying that, the next feature that you can do with this free version is you can manipulate the shape data component. Now what I mean by this is like you can suppress, unsuppress different components of the assembly. Now let's say if I want to suppress the base, I don't want this to have a base, like I just want just want the walls. Okay, so what I will do is I will like get the name of this particular component or like this base. I will put the assembly name you can copy the assembly name. So this is not working. Let's go here and let's change document properties. No, not like this. Let's go here and say rename. So this is the option that you need to activate to get the names from there. Let's click OK. Let's do a right click. Let's say rename assembly. Let's get the name, paste the name here, and then you need to mention whether you want to have the file suppress or unsuppress when the utility will run. Let me go ahead and delete this. So here, see, what I did is I put the model name, the assembly, and the state how I want it when the utility will run. Now let's go ahead and save this. Now again we will run the utility to see if the changes has been implemented. Okay, I certainly doesn't want to open Solidworks 2019 window, but yeah, I'll look into it so that during the development phase Solidworks doesn't launch several times. Okay, now let's see how this will go. So logically, like how we configured it, the base assembly should get suppressed. So let's see. Oh. Okay, let's close everything. Let's close this also. And let's go to our config data. Let's expand it. So this is shape data component. That's good. Put part 1 test assembly suppress. Control set. Did we saved it? Let's save it. Let's run it again. Okay, so you can see that the part hasn't been suppressed. So the problem is you always need to mention the instance of the component, and as earlier we haven't mentioned the instance, that's why the part is not getting suppressed. So this should suppress now. Let's see, save, we will save it, and then we will go to our software and let's run it back again. So once it's started, it will go to the file, read the Excel, open the file, and then should suppress the base. So this way you can have a control over your shapes, like the configurations that you want to create shape. Let's say you have some assembly where you want to suppress a few components depending on the your configuration needs. So once this is done, it should suppress. See, now it's selected the base component and it suppressed it. You can see now it's empty. Okay, so this is how you can suppress components, and the similar way you can mention the features. Let's say if I want to suppress this boss extrude of this particular feature for my configuration depending on the input. So what you can do, you can mention the state whether you want to have this suppress or not for a particular configuration input. So you can create different kind of if else statements here. So let's say I want to suppress this feature only when the length is more than 200. So similarly you can create the suppress unsuppress options depending on this inputs by utilizing the if function. Let's say if I can write it, if demo length is greater than 200, then for how this if works, whenever value if true, so if this logic is true then this value will come, otherwise suppress. So this is how you create a value. So once you create the formula, depending on this demo length, the other things will going to come. Now you can see it is giving some error. Let's see. If I go to dimension CAD, if I go to input outputs, length is 900. So accordingly, shape data component, shape data feature. So what we should get is, you can do it like this, because these are strings. Okay, so the length is greater than 200, then suppress. So this way you can create logic for suppress unsuppress, both for shape data component and shape data feature. Now you should always follow this syntax, like you need to provide the feature name, part name. So I kept these two rows as a sample, so you can keep a note of this rows, and whenever you create your own configurator you can change all these values accordingly. So with our free version you have these three sheets that you need to change so that you can do the changes inside the CAD, and here you need to provide all your input values. Now let's say if the user change these values to some 1000, let's say this I want as 500, and this I want as 800, and this I want as let's say 10, and if I save this, and I can close it, or if I want, if I don't want, that is not mandatory. Now let's say, so don't save your master model, so because that is your actual master model where all the modifications are going to happen. So with this free version, what you need to make all these changes, and then once you are final with the change, you can launch the console application. And what this console application will do is it will launch Solidworks and do the modifications accordingly. So now the values got changed, you can see. So I think it's currently, I think it will, yeah, it suppressed the base component. Now see, all the values got changed. Now once this is done with the free functionality, we don't provide any automation with the save. So once you are done, you can save your outputs. See, nothing got overlapped because we had equation. So this way you can configure any assembly. So yeah, this is how you configure assemblies with our utility. And I want to reiterate, this is a free utility where you can do all the modifications to your CAD. It can control the size variations, like however you want to change the sizes, and also it can control the shape variations. So once you evaluate your model with the utility, whether that can be configured or not, if you want to extend your services and provide it to your customer, and provide it to your sales department, different departments, then please visit www.cloudcad.com for more information. Thank you. I hope this will help you, and if you get into any difficulty, please contact us. Thank you.